Welcome all to CE for Civil Engineering classes. So in this session, we'll see the activated sludge treatment process, which is a part of the treatment system in the environmental engineering. So to start with, activated sludge treatment process is defined as a secondary treatment system. So what is actually a secondary treatment system? It is actually example of a biological treatment system where the microbes are used. It is an example of the biological treatment system where the microbes are being used to bring about the treatment. So what is being treated over here? In a secondary treatment system, the main aim is the BOD removal. So we'll just see how a treatment system for a sewage work look like. So you know that it will be having a screening followed by grit chambers to remove grit, a skimming tank for removal of oil, grease, etc. And that will be followed by a primary settling tank where the settleable organics will be removed. And finally, the what is left is the dissolved organic matter, and that will be actually removed in case of a secondary treatment. And ASP is just an example of a secondary treatment system. So here it is a biological treatment, that is bacteria is being used, and BOD removal is actually taking place. So how much percentage removal is happening? About 80 to 95% of BOD removal occurs in an activated sludge treatment process. So this particular treatment system is suitable for large sized towns and cities, and you can say this as an example of a suspended growth system. Why? Because here the bacteria or the microbes which are used is in suspension in the system. So they are in suspension, so they are not attached to any media, but instead they will be suspended in the media. So to know more about it, we will see how a activated sludge treatment system works. So after the primary settling tank treatment, the effluent from this primary settling tank is being fed onto an aeration tank, which is a part of this activated sludge process. So actually, if you are asked what is the components of an ASP, you can say that an ASP system has got two components. That is, one is an aeration tank or an aeration chamber, and the second one is a secondary clarifier or a secondary settling tank. So these two are the components of an ASP. So PST or the primary settling tank is not a part of a secondary treatment, whereas it is a part of a primary treatment. So ASP is the part of secondary treatment, and its components are an aeration tank and a secondary settling tank. So what is happening in an aeration? Compressed air will be circulated in the aeration tank. So here in the aeration tank, our wastewater, which contains this organic matter, will be there, plus the waste will be containing the microbes or the bacteria, and then we are supplying oxygen also. So this bacteria will utilize the oxygen to bring about the complete reactions or decompositions of the wastewater. So you can say that an ASP system is an example of an aerated secondary or an aerated secondary system, or it is an aerobic secondary system, or you can call it as an aerobic secondary treatment system, because here the bacteria which is working are the aerobic bacteria that comes in the sea. Now the mixture of this organic matter plus bacteria plus this oxygen is together called as MLSS. So MLSS stands for mixed liquor suspended solids. Mixed liquor suspended solids. So it is simply the mixture of this organic matter plus the bacteria plus oxygen. That is what you call as a mixed liquor suspended solids. Now, so the bacteria and organic matter and this MLSS will be in a turbulence inside this aeration tank, right? And as a result of this reaction, something called as flocks will be formed in the aeration tank. So as a byproduct of the bacterial reaction, something called as flocks will be formed, and inside the aeration tanks, this flocks will be in suspension because compressed air is continuously being circulated, right? So what happens, in order to settle, in order to remove these, we'll transfer the whole contents into the secondary settling tank. So where these flocks will settle at the bottom. So they are made to settle at the bottom, and the remaining effluent will be there. The effluent may be subjected to a tertiary treatment such as chlorination, etc. And the settled flocks, that is what you call as a sludge, or in general you can call it as an activated sludge, from which the name activated sludge process comes. Now why is it called as an activated sludge? Because in this system there are active microbes which are present. Active microbes are the live bacteria. Here you have that organisms, they will be transferred, a part of them will be transferred, of course, through the flocks, right? So there will be this active microbes which are being recirculated into the aeration tanks. So uh, it is because of this active microbes or microorganisms that we call this particular system as the activated sludge process. So they are actually being recirculated in the form of the sludge into this aeration tank. So why are they being recirculated back to this aeration tank? Because as I said, they are active microbes, because they have been already acclimatized to doing this particular job. That is, once they have started decomposing or degrading a certain kind of waste which is coming, so they have experience of degrading this kind of waste. So if an experienced person does a certain work, it will be completed faster, right? So that simple logic is applied here also. So this active microbes is already acquainted to this particular kind of waste. So this process will be faster if they are being recirculated into this aeration tank. So this is the whole process that is happening in an activated sludge process. The process goes on, and finally in the form of sludge, you will get the BOD removed, and the effluent will have almost 80 to 95% BOD removed in the form of the sludge, and this sludge wasted can further be dried and subjected to the sludge treatment processes. So thank you all for watching CE for Civil Engineering. If you like the videos, please like and subscribe the video. Thank you.